Writing modular code. So far all the assembler code you have written has been in one main function, which in assembler is called a subroutine. This is fine for very small programs, but as you add more functionality to your code, it's much better to break the overall task into smaller chunks, each of which has its own specific task to perform. When each of these separate blocks of code, or subroutines, is called in the proper order, the overall task is accomplished and your code is much easier to test, debug, and maintain. In the instruction set video, we looked at the instructions that can control or change the natural sequence of a program's flow. This includes the branch instructions that we've been using for decisions and repetition blocks. The jump and call instructions will be particularly useful for us in this session because they're provided specifically for writing modular code. As I said earlier, dividing the overall task up makes it easier to write, test, and maintain your code. The goal is to do very little work in the main block of code, with all the real work shuffled off to one of the subroutines. In this pseudocode, we're going to show the main doing some initialization and then calling a series of subroutines. Notice the keyword call. This indicates that the program flow will break from the norm, moving to the starting address of the specified subroutine. Then when it's finished that code, it will automatically come back and continue executing code in the main block. The structure of a subroutine is almost identical to that of the main block of code. The main difference is the terminating instruction. The main block uses a software interrupt, while the subroutine uses a return. It's important to always include this instruction at the end of each subroutine so that it returns back to the calling subroutine properly. Notice here also that sub1 has been called twice. This is one of the advantages of modular code. You can reuse blocks of code without having to rewrite them. You know that in any programmer's model, you'll find the same three types of pointer registers: the instruction pointer, one or more index registers, and a stack pointer. It's because of the instruction pointer, or program counter, that this session on writing modular code is covered in the pointer register lesson. Since this register identifies the next instruction to be executed and is automatically updated as each instruction in a program is executed, any time we deviate from the defined order of instructions, the instruction pointer has to be involved. The nice thing about these instructions that change the sequence of instructions is that they take care of any changes to the instruction pointer all by themselves. So as long as you choose the proper jump or call instruction to get to your subroutine and always include a return at the end, the instruction pointer will always be updated so that it's pointing to the next instruction to be executed. So to recap, where non-modular code has all the instructions in the main block, modular code divides the instructions into separate functional blocks. This generally makes your code easier to write, test, and maintain.